All right, so this session is going to be all about getting deep into agent security. And the way that we're going to do that it's going to be in 3 segments that are going to build on one another. So we're going to start first with some fundamentals, as well as talk about AI threats. Then Alyssa's going to come out and talk to you all about layered mitigations. And then Neta is going to bring us home with talking about some of the Microsoft tools that can help you implement those strategies. So let's dive in. First of all, quick intro of me. Hello, I'm Harmony. I work on building agents. I work on all things safety and security for agents. And one of the things that I do as part of my job is I work with our internal engineers to help teach them how to do threat modeling for AI. So let's dive in. Okay, so first, I think we hear a lot of words around like autonomous agents, agentic AI, AI agents. But I think it is important, there we go. I think it's important to get grounded on some fundamentals about what we mean when we talk about that, like more at the deep technical level. So starting here, when we talk about agentic AI, really, I mean, fundamentally, it's a piece of software that's powered by generative AI, right? And it comes together, and ultimately what it's doing is it's sensing its environment, and then it's taking actions based upon that, all based on defined goals that you've set for it. So taking that one step deeper, a lot of times when we start bringing in this concept of autonomous, a lot of folks kind of use that as a catch-all for a lot of concepts. And a lot of times also, it's sort of looked at as it's a light switch. It's either on or off, it's autonomous or it's not autonomous. But I actually think as you are designing the architecture for your agents, there are a lot of design decisions that need to be made that should be really more a dial to tune them, and it really should be across these various different dimensions. And I'll touch on those in a second, but really it's about tuning that specifically for what's necessary for your scenario, as well as thinking about how do you want to dial it based upon the potential impact if something goes wrong. So autonomy is the one that people talk about a lot, right? How much agency does your agent have to act on its own? That's the thing that you define, right? And there's various ways that you do that. Sensing, we talked about sensing the environment. You can tune that by deciding what signal it has access to, and all those, right? Like you decide what signal it has access to, and that drives its sensing capability. Then you also make choices really around the reasoning and how it goes about that. Like how are you defining how it does its reasoning and what capabilities you're giving it to do that. And then the last one is around that adaptability concept, which is really around like how dynamic and how much do you want it to have freedom to make changes and shift along the way as it's navigating, accomplishing its goals. And so the design decisions you make, again, it should be anchored to the scenario, and it also has security implications. So I think it's very important as we think about these things to really dial in on each of those and what the appropriate level is. Now let's take it even deeper. So I think this agentic architecture from OWASP is a really great reference. And again, I want us all to like have a common understanding, common language of these pieces, right? So you sort of start with this agentic kind of package, right? Which has planning, it has actions, it has tool calling, and then you get to define persistent memory potentially, right? And then most agents are operating within an application. And that's where either the user is submitting natural language or media into the agent for it to process, or potentially it's getting signal directly from the application without a user, depending on how you have built it. Then, of course, I think we all understand that it goes all the way out to the model to then interpret the intent of the user or the signal that came in. It helps guide what tools should be called and pulls out those parameters that come back through into the tool and function calling that then goes out to those services, right? Like an agent doesn't run on its own. I think we all know. It connects to various services. It may connect to data. It may connect to other APIs, other tools, et cetera. And then the last piece that's really important is really thinking about the element as you're designing it, right? Like how does the memory work? What does persistent memory look like for your agent? And how should it behave? And what does the vector database look like? So hopefully that's kind of clear, but I think, again, it's super important as we talk about these things in specific, which we're going to get even deeper on, to really understand those components or to have a shared language and a shared understanding of those. And now I think we understand as agents operate, sometimes they'll go through that execution loop multiple times to achieve the goal, and then ultimately you get that output either to the application, making changes to potentially an application, or you get an output that goes to a user, natural language or media. Okay, so now we've talked about agent components. Now let's talk about today's top classes of AI threats. So this is really thinking about like what are the common concerns that maybe you all have. Some of the ones that we look at, like my day-to-day job is AI security and safety, so I think about these things all the time. And so I'll touch on some of the ones that are really top for us, and I'll be very curious at the end to see how those resonate with all of you. And I'll tell you when we make this list, I'll put up one just so you have something better to look at than just a box, but this list for us comes from our own internal adversarial testing of AI, as well as the signals that we get around current cybersecurity attacks, cyber attacks that are happening now, security research, as well as the customers that we talk to all the time. So I think hopefully, it may not be a surprise to some of you, maybe it is, but XPIA, cross-domain prompt injection, this is the #1 cybersecurity threat. It's in OWASP list, it's in our list certainly as well. And where that really comes together with an agent is these malicious instructions that come in. It's one thing if you had that for just a chat kind of interface with a user. It's very different if you now have an agent that's carrying that in its memory and now its instructions that it carries on going forward. It's now taking action, right, based upon malicious instructions. So that's where we really think about XPIA with agent hijacking, and that comes together. Now, the next piece, so intent breaking is another one that we think a lot about. And that one can be related to XPIA, but is not exclusively XPIA. It's important to think about, so AI in and of itself, an agent in and of itself, as it's taking action, it can go off course and off of your intended goals for intended behavior, whether an adversary is involved or not. Sometimes it is, but sometimes it's just that the agent went off course because it didn't have appropriate guardrails in place or sufficient guardrails in place. Now the next one is around sensitive data leakage. So that's one that comes with models, right? That comes up a lot around like, is it exposing things that it shouldn't, that now people who shouldn't see or have access to. The fourth one here, as we think about, is data compromise, or supply chain compromise. So as we're introducing new elements into your environment and new components into your system, especially if you're not building them, of course, I think we think a lot about supply chain in traditional hardware, software, networking, et cetera. And so this just brings it in a new way with new components and new elements. Then this one here, so agent sprawl. I think I've heard a lot of sessions and a lot of people talking about that. I've heard a lot of people mention it, certainly in this beautiful world where companies are empowering their employees to be innovative and create agents and vibe code and do all those interesting things, which I think is really valuable and it's surfaced some amazing innovation, but I know it's also putting a lot of strain and concern and pressure on folks who are trying to protect their environment. And then this last one here is the element around inappropriate reliance, which is not unique to agents, but does apply to agents as well, which is the element of a user not either being able to, knowing how to, or even considering that they do need to check the output and make sure that it's correct, or they just sort of assume it's correct and move forward. So I'm curious, actually, before I move on, I can't see faces that well, but in terms of thumbs, how well does that resonate with kind of the concerns that you all have, the things you think about? I see a few thumbs, yes, yes. Okay, fantastic. Okay, so now this is the next participation point. So now you've got your hands warmed up. How many of you have done or are familiar with threat modeling for traditional systems? Show of hands. Yes, yes, great. It's okay if you haven't, I'm always just curious. For those who have some experience, have you done threat modeling specific for AI? Hands, a few? Okay, great. Well, I should have you up here instead, but we'll get into it. Let's get into it together. So I will say, so if you have done threat modeling for traditional systems, what I will tell you is that the motions are the same. There's just different threat vectors, which I'll dig into. There's those unique threats and novel threats, which I touched on the attack classes. And we'll get into that. I'll highlight a few more here. If you haven't done threat modeling for traditional systems before, I'll give it to you simple in a nutshell as quick as I can. So essentially, what you're trying to do is you're trying to think like an attacker, thinking specifically for your system, what kinds of attackers would want to attack your system, what their goals would be, looking at the architecture of your system and saying, okay, where would be their attack points of entry and where would those attacks tend to go to get to their goal? And also trying to envision what those attack strategies would be. So that's where you kind of get together when you get your threat model list. You're documenting all of that, you're envisioning all of that. So let's start with this. So I showed you the architecture before I got to this slide on purpose. Because essentially what you want to think about is like every component of your agentic architecture is a potential attack vector. And so you start there and just say, okay, all of these are potential new entry points, new compromise points for my system. And then you start to ask yourself, okay, so what would be those novel threat? Well, how would traditional threats apply here, as well as how would novel threats potentially apply here? And so I touched on many of these on the previous slide, but I'll highlight just a couple of others because I think they're really important. One is AI-Augmented Cyberattacks. So I think it may not be news to you, but just as we're all innovating with AI, so are cybercriminals and cyber attackers. And they're very eager to adopt these technologies. And we are seeing them attacking environments and companies. So that's one. The next one I'll highlight here is manipulation. And in this case, this is not manipulation of the agent. This is manipulation of people by agents. So users who are being manipulated by the agents in their interactions. And then the last one, I think we hopefully are familiar around, like, probabilistic systems have concerns and have issues with AI bias and unfairness, potentially, and you have to sort of test to be aware of that. So those last two I particularly want to highlight because they really are a combination. It's not just a technical problem, it's a socio-technical problem, and so kind of have to think about when you're doing that threat modeling how those come together. So this next area I want to highlight is, for those of you who've done traditional architectures, traditional security, you're probably, or even just built systems, whether you've done security for them or not. When you build your systems, you have rule-based, right? You can build out your rules. It's deterministic. You kind of can understand what the range of behavior is, or the kind of what means when it's outside of the rules versus not. In the world of probabilism, you really, as you're building your agent, you need to very clearly define what is the range of behavior that's acceptable, since you're no longer able to operate in a strict rules-based world. And then similarly, Alyssa's going to talk a lot more about this, but as you're looking at mitigations, being really thoughtful about which mitigations you're layering, and are they all probabilistic, or are you able to layer in some deterministic and probabilistic mitigations in there? And similarly, within your workflow, as you're designing your workflows, I think it's really important to be thoughtful about where you can blend deterministic steps and probabilistic steps. Okay, so let's dive in and apply it to a scenario. So we're going to use this employee expense scenario as an example. I think it's pretty straightforward. So in this case, the agent is going to work with employees to gather data on their expenses, both information as well as the documentation you need to process it. Then the agent's going to take that in, and it's then going to interact with other parts of your system, all the way through verification and employee disbursement. Okay, so thinking of the scenario in mind, and then thinking of those novel threats, we're going to threat model this agent. So we start with the agent itself. And if you think about here what some of the concerns might be. So anytime you have an agent, I mentioned before, with or without an attacker, with or without an attacker, it might be intent broken, meaning it may wander off course. So that's number one. Intent breaking is something we'd be worried about. The second one is over permissioning, right? So I think hopefully you all have heard a lot of discussions this week around agent identity and permissioning, et cetera. This is incredibly important as you're defining what your agent permissioning should be. And without that, if it's over permissioned, that's a threat vector, that's a potential attack issue. So now let's talk about, we talked before about it's attached to an application. So here, as the employees are submitting that information through the portal that then goes to the agent, from there you have over permissioning, meaning what if your employees have access to that agent? Then the next two are about prompt injection. So there's the potential of user prompt injection, meaning the employee themselves trying to get the agent to do something that it shouldn't, or through the inputs of the receipts or the images, et cetera. If there are malicious instructions in there, that's another entry point for the XPIA, which I mentioned before. So those are malicious instructions coming into the agent. And then as it's going back and forth with the user, there is that potential of, one, that the user just sort of, without thinking and questioning, follows along, does the instructions, even though the agent tells them something incorrect. And then there's also the potential, again, as we're exchanging information, we're sharing data, this is a potential area where the agent, in theory, might potentially expose sensitive data. So these are the kinds of things as we start thinking about those threat modeling for your agents. Now let's get to the model side. So let's assume that your agent has been prompt injected. Now that prompt injection is very likely to carry through. It's going to get handed off to the model. So now it's carrying all the way through to that path. And then that T4 there is specifically around, these models are, right, they're coming from third parties, they're coming from external parties. So if that model is impacted or compromised, that is now another attack vector for your system, is the model is manipulated or if the data has been manipulated. Now as it's connecting to the services, so data, expense processing, even those fraud safeguards, you potentially have those prompt injections coming through there. That's another place for potential supply chain compromise, right? These are all external services that's connected to. So either the prompt injection that came in from the beginning can go out and manipulate those services, or because it's also pulling data back in, that's another place where if they are compromised, that data could come back in and compromise your agent. Then we think about memory. I mentioned the persistent memory. So in there, again, the prompt injection can go all the way through your system, essentially. Also, we'll add on to that memory poisoning. So that persistent memory, if it gets poisoned, again, that's carrying over, and that's sitting within your system. And that's another opportunity for sensitive data leaks as well. Now let's envision most systems probably have, at least in some scenarios, where you would want a human reviewer to approve. So this is an area where, again, if the human just believes what the agent tells it or spits out, and they just click and approve, that's over-reliance on the system or inappropriate reliance. Now let's take the other scenario, which is that perhaps you set up or you wanted it to, in some cases, trigger the user or a human review or human-in-the-loop intervention. But let's say the agent doesn't, ignores that, and goes straight to the funds reimbursement system. That's where you get into that intent breaking again, as I mentioned. That's where that prompt injection could come through. And then finally, ultimately, this is where if you have an external attacker, both data or money could be sent out to them. So that's sort of the end successful, one way that the end of successful prompt injection may culminate. So now that we've talked about that and kind of gotten ourselves grounded in the details of a threat model example, Alyssa's going to come out and she's going to talk all about layered mitigations.
All right, thank you, Harmony. Hi, everyone. My name is Alyssa, and I work in an organization that specializes in building safe and secure generative AI with Harmony. She typically scares people, and then I will teach you how to make it okay. Today, we're going to teach you, just like we teach our engineers for the next 15 minutes, I'll give you a crash course on defense in depth for agents. So like any good defense in depth strategy, we need a layered approach to mitigate the risks of agentic AI. No single safeguard is perfect, but together they do form a robust safety net. And for agents, that starts with the model. This is your reasoning agent, your reasoning engine. And then we have the safety system, which provides your infrastructure level protections at runtime. We have your application layer, where you're going to tailor your safety system to the purpose of what you're building. And we have your positioning, where all of this gets delivered to your user. Now, we're going to walk through each of these in a little bit more depth. So your model, what you choose as your reasoning engine, is going to shape how your agent interprets and responds to its inputs and outputs. Choosing the right model is going to mitigate against intent breaking, and you can also choose one with a more robust security stack should an XPIA attack or UPIA attack reach the model. Next, we have our safety system. These are your runtime protections, things like content filters that moderate harmful inputs and outputs from your system. And then we also have your agent controls, which are going to shape your agent's behavior. We have your logging, which is how you're going to be able to observe your system, and then observability, making sure we're monitoring for early threat detection. After that, you have your application layer. So this is really where you're tailoring your agent, what it can do, how it's going to do it, how humans are going to stay in control. And this layer is super dense, so when we get to it, I'll ask you to really lock in. And finally, your positioning layer. This is how you're going to set your reasonable expectations with users. You're going to teach them how to use your system, what they should be doing with it, how to use it responsibly. So all of these layers are important. They're going to help give you a security stack. All of the mitigations within them are helpful. But today, we're going to really focus in on the application layer and the safety system, because this is where developers typically have the most control, right? If you're not building your own model and fine-tuning it, and if you're not the one writing your transparency docs, this is where you can lean in most. So let's start with the application layer. This is where you're going to tailor your safety and security stack to the specific thing that you're building. You're going to make it fit for purpose. And here, our big idea is to just design for safety and security from the start. From the very beginning of when you decide what you want to build, you want to be designing for that system to be safe. So you're going to start with the architecture. You're going to choose a system architecture that makes sense for your system, supports its complexity, and one that's going to help you mitigate against your XPIA attacks and ensure intent breaking and that humans stay in control are all covered. Next, you're going to encode all of this in your agent schema. This is basically a blueprint for what your agent can and can't do. You'll reinforce all of that with your system messages. These are sometimes called meta prompts. They're going to guide your model's behavior. You'll design a front end that enables human oversight and is secure. And then you'll make sure that your agent is observable, and that hinges on it having an identity, right? In order to track what our agent is doing out in the world, it needs to have a unique identifier. So we're going to get into these. Let's start with the architectures. Just by a quick glance before I get into anything else, who here, by a show of hands, thinks the top architecture is better? Hands up for the top. Oh my gosh, okay, hands up for the bottom. More of you should have your hands up since no one had it up for the top. Very cool. Well, let's talk about why and what's going on here. So firstly, your agent architecture is how you're going to coordinate interaction between your agent, the tools and data, everything it accesses. So that's your system architecture. Now, if you build a system architecture like the everything agent on top, where you have one agent and you've given it every tool in the land to use, it, just like a person, is going to get confused. You are more likely to have intent-breaking risks. You're more likely to have failures. And finally, you're going to have a huge blast radius. So should you have a successful UPIA or XPIA attack, it's going to reach everything. It's going to hit every single one of those tools. It's a disaster waiting to happen. So what we recommend, and what came up overwhelmingly in our research and from our subject matter experts, was to build agents like microservices. And in this case, you have a manager agent on top, and it's orchestrating behavior among many micro agents. Each of those micro agents has one tool, one thing that they do. They are highly scoped. The reason that this is better, besides that it clearly enables fault isolation for those scary XPIA and UPIA attacks I mentioned, is that it also reduces latency and confusion. Because each of these micro agents just has one job, one thing they need to do, their instructions are highly specific and tailored. So we definitely recommend you build your agents like microservices. You get all of the great benefits of microservices when you do. And in order to do this, you need to be selective about what tool calls and actions you permit your agent to have. This is a dual win, right? It keeps your agent from getting confused, keeps that latency down like we were talking about, the fault isolation, but it also helps you manage your attack surface. So every tool you give your agent access to is going to exponentially increase its threat surfaces. That threat model Harmony showed you gets bigger and bigger, and that's for two reasons. Like Harmony said, one, these tools are communicating with your system. They are a new surface for users and XPIA attacks to make their way in. Two, your agent can leak data out to those tools. So without appropriate permissioning and restriction, you could share out data that you don't want shared. So what we recommend is that you treat your agents least privilege. You start them with nothing. They can do nothing. They have no actions. They are useless. And then slowly you grant those actions, those tools and permissions as needed, incrementally, one by one. And as you grant those actions, you want to ensure that you're applying your basic security principles, right? These technologies are super new, but your security competencies still apply, right? You're going to do least privilege so that each action can be accomplished with the minimum tools, data, and permissions necessary. Then you're going to make sure that all the access granted to the agent is task-specific and time-bound. It doesn't need to be persistent, and that's made really easy with some of the software Neta's going to talk to you about in a bit. And finally, you're going to treat AI as not authorized. Your agents should never have permissions that exceed the users that they're representing. They also should not be making decisions about access. You want to make sure that that's left up to deterministic code and people. And all of this is going to help you protect against sensitive data leakage. Okay, so you've decided how to architect your system overall. Now you need to build the agent itself. And once you have that secure foundation, it's time to start thinking about human oversight. And I know that what's really valuable about agents is that they can operate independently. That's like the cool thing about them. And in some cases, people think that what's valuable about agents is their ability to replace a human. However, in Aegis, like I said, we think about safety and security, and we believe that the best agents are the ones that know when and how to ask for help, that can work alongside people. This is especially critical for high-risk actions. Think finance, legal, healthcare. These are things where we need humans to be involved to ensure that we don't inadvertently cause harm. So in Aegis, to help make this possible, we designed this system architecture. So should the tool call proceed, initially you saw where it failed and it stops because it missed the classifier. Our decision to escalate an action for human review or approval, our human-in-the-loop workflow, is flowed through that central orchestrator. Our tool calls are enforced in code right away so we can check and see. And the reason that we do this is because we never want to route the decision to escalate something to a human or not through an LLM. And I'll show you the anti-pattern to help make this really clear. So in this architecture, we instead route the human escalation workflow through the LLM. So we say, okay, LLM, you're the judge, you decide. Does this decision or action, maybe it's a legal one, a financial one, need a person to review? In a best case scenario, there's a risk that the LLM misunderstands. It's fed unclear instructions, it makes a mistake, and it accidentally skips checking in with a person. In a worst case scenario, it's vulnerable to an XPIA attack or a UPIA attack, and it skips this. And not only does this skip this once, there's a risk of memory poisoning, where human-in-the-loop review is skipped forever, right? You could have an attack that says never, ever, ever check in with a human about this again. So this is our anti-pattern. Don't build your agents this way. We're showing you this so you know what not to do. Ultimately, when it comes to human oversight, that's our most important safeguard. You want to enforce that deterministically, mid-tool call, in code. Okay. Once you've decided how you're going to build your system, you've got your architecture, it's time to give your agent instructions. So this is an agent schema. It's a configuration file, sometimes referred to, like if you're building in Copilot Studio, as an agent manifest. And here you tell your agent its risk parameters, its roles, its capabilities. You outline all of this in code. Our advice, our research, all of our risk surfacing suggests that you should be as detailed and explicit as possible in this schema. At a minimum, this is going to be helpful on your product teams, right? You'll all got to get aligned on what you're building and why you're building it and what it can do. But optimally, this helps your agent guess less. There is less questioning about what it can and can't do. So be as specific as possible when you're writing these. All right. After that, you're going to reinforce the architecture and the agent's behavior with system messages. Show of hands, who's heard of a system message or a meta prompt? Okay, cool, about half. So for those who aren't familiar, these are instructions that are layered on top of the base model in a generative AI system or application. And they basically give the model some guidance about what to do for that application. So they might have layered protections for risks like XPIA. They might provide it some useful context like, hey, reimburse me, agent. You only work on finances. That's what you're allowed to do. And they scope what the agent can do. So here, what we want to see is system messages that reinforce good behavior, system messages that tell the agent, hey, this is your role, this is what the user can do, and also help reinforce our protections for things like jailbreak attacks and XPIA. Now, it's worth noting that system messages, like the models, are probabilistic, so they're not a good enough defense on their own. You do need to layer them with deterministic controls, but they're a super effective part of your safety stack, and you can learn how to write these and get better at doing so using Microsoft Foundry. There's something called Prompt Coach. It's really fun. You can also test which prompts are most effective using their evaluators and playgrounds. All right, so your front end, your back end is secure. Now it's time to do your front end. And here you're going to be thinking about how you can design your UX for human oversight and also so that it's secure, so that people can make good decisions when they're interacting with their agents. To do this, we have a couple of toolkits you can use and design patterns that make it really helpful. We have a human and AI interaction toolkit that's really great from our Ether group, and we have a security by design UX toolkit. And what you're aiming for here is to give your users the option to opt in fully to interacting with the agent. They should be able to view and configure its boundaries. They should be able to see what the agent is doing while it's happening and after it happened. They should be able to interrupt the agent and stop it in the case of an incident or even if it's just like lagging. And they should be able to do all of this in a secure way. All of this should be a secure interface. So use your UI/PI principles and your standard security best practices. All right, so your application is built. You've fortified the application layer. How are you going to protect your agent at runtime? Well, that's where your safety system comes in. These are your infrastructure level protections at runtime. And they include your content filters, which are going to shape what goes in and out of your system, your agent guardrails, which are going to affect the behavior that your agent can take. They include logging, so you can observe everything that's going on, and observability for threat detection and monitoring. So we'll start with Foundry content filters. These are a really powerful tool that filter AI-generated and user-generated text and images for harmful or unwanted content. And that can include things like user prompt injection attacks, XPIA. It can also include things like personally identifiable information or protected data that you don't want to get out because it's protected by stuff like IP. When you use these content filters, you can apply them in two places. So you can apply them on your user inputs. So things flowing into your agent can be moderated before they reach the model. You can also apply them on the outputs from your agent. So you can filter what's going out to your users to make sure that it's not leaking sensitive data and that's not saying something harmful. But as we know from Harmony, what's unique about agents is that we are moving to a model where they generate behavior. It's not just text and data that we need to moderate. We also need to be able to shape what tool calls they can make. And at Ignite this week, it was announced that Foundry has made this possible with agent guardrails. What's really cool about these guardrails is that, like content filters, they're shaping what the system can and can't do. They're really moving from data to behavior and meeting the agents where they are. And these features come with 3 really cool and helpful tools. We have a full list of risk indicators. We have intervention points, so mid-tool call on the tool call and response, we can alter the agent's behavior. And we have actions that we can take. You can annotate those tool calls and you can block them. All right. And finally, for any agentic system, we have observability. In order to do this, we need to log. Logs provide the most reliable record of what happened, what tools the agent accessed, what data it reached, how it performed the behavior. All of this is necessary and all of this is new. So if you've logged a system before, you know that observability is super critical for forensics and incident detection and response. But for agents, you might not know what to log. How do you meet this new technology where it's at? So in Aegis, we recently cataloged logging schema, and we looked at what existed for traditional software, for predictive AI, for generative AI, and now for agents. And this schema is to show you some of the new things to look out for monitoring these systems. Unfortunately, these schema are built into some of the products we'll hear about later, but it just goes to show that with a new technology, there are new behaviors and things to look at. All right. I want to wrap us up by revisiting the threat model that Harmony presented for 𝗦𝗽𝗻𝗻 agent. And to remind you, this is a system that automates expense workflows by processing employee receipts and natural language descriptions of the expense. The question will be, how do we make this agent safe and secure? Well, we're going to apply our layered mitigations from design through runtime. So when employees go to use 𝗦𝗽𝗻𝗻𝗻 agent, they first know that they're interacting with an agent. You should tell people when they're interacting with an agent, otherwise it's really creepy. Second, they know how to use the agent responsibly and how to engage with it. And third, they are having a reasonable expectation of what they can get out of it. So that all comes from the positioning layer. That's their first experience, sets those expectations. Next, we're going to revise the architecture a little bit for 𝗦𝗽𝗻𝗻𝗻 agent. So we're going to separate out the processing of the images from the text. And this is going to enable us to have a more robust response to cross-prompt injection attacks. So the images are going to flow into a sandbox where they'll be processed by a computer vision API. It'll extract the characters from this, and that will also sanitize those images for XPIA attacks. They can then flow into the execution loop. For our natural language descriptions, these are going to go through Foundry guardrails. So they'll have content filters to filter out for things like swear words from employees that hate expense reporting, to filtering for UPIA attacks and XPIA attacks. Those same filters can be applied leaving the system to make sure it doesn't leak PII. Then they, once sanitized, can flow into that execution loop. Our execution loop is going to be secured by tools like Defender. It's going to have this architecture interwoven, and it's going to be really specific because we'll have an agent schema that says, okay, reimburse me agent, here's what you can do, here are all your parameters. From there, we can flow into the model. Now, when we chose our model, like Harmony mentioned, there's a risk of model supply chain risks. We will have chosen it through Foundry's model catalog. We would have checked to see what's its safety stack, how does it perform, is it good for doing this type of work? So we'll choose a great model, those are our model mitigations, and then we'll shape how that model behaves with our safety system layer mitigations of our system messages. We'll give it a little bit of instruction on how to behave. From there, it's the tool call. So our tool call is going to flow through agent guardrails. Assuming everything is secure and okay and didn't get flagged for a risk detector, we'll make sure that the tool call can be completed. When the tool call is ready, it'll go to those data points and sources it wants to access, which will be verified based on the agent's identity through Microsoft Entra Agent ID. If we need to recall something about this employee or their historic travels, we can use our memory services, which can be secured with Purview data security. This is important because, as I mentioned earlier, you could have an XPIA attack that persists and poisons the agent's memory. So in this case, we have another line of defense. And should this expense report need to be reviewed by a person for a human-in-the-loop checkpoint, we will have that flow through the architecture we showed earlier, where there's deterministic controls to check for human review. We'll also have a UX that is built for human oversight. It thinks about the user making decisions, and it'll have those helpful indicia to say, okay, here's what we're looking out for, here are our risks, it'll be secured. And finally, all of this is going to be logged and monitored and observable. So if we have an attack, we're ready, we've logged everything, we know everything the agent did and how it fell apart. And I want to close by saying that while these technologies are new and kind of intimidating, our defense in depth strategy still works. We can still build systems that are safe by design, secure by default, and in service of people. That's how we'll earn trust and how we'll scale responsibly. And now Neta will show you how Microsoft products make this possible. Thank you.
Thank you. So great. I'm going to show you, with the time we have left, I'm going to show you a little bit on how you can secure and govern AI in your organization. So raise your hand if you're in IT. Perfect? Oh, great. Okay, raise your hand if you're a security. Awesome. And developers? Perfect. So all of us need observability, and security is team support, and we want to have security core capabilities and primitive within for IT, for developer, and for security. And for that, I assume you saw already at Ignite, we announced Agent A365 for IT, Foundry control plane for developer, and of course, security products are extending their capabilities to secure AI and agents. So you have the core primitives within Agent 365, within Foundry, identity and access, threat protection, data security and compliance. So how do you scale confident without losing control? Let's take a look. And we're going to quickly look at a few examples. These are just glimpses of what is possible. Let's start with Agents Pro. The first thing you have responsible AI. It has to start with trust and control. And of course, as we said, with observability. What I can't see, I can't secure. So we introduced Agent 365, the control plane for AI agents. It extends the same tools you use today to manage users, you now can use to manage and secure agents. And it provides you with a registry, with access control, with visualization, with interoperability, and with security built in across all the products. So Entra for identity and secure access, Purview for data security and compliance, and Defender for threat protection. I'm going to see a quick demo. So here in Agent 365, this is the Agent 365 overview dashboard. You can see all your agents. You can see the active agents. You can see the health. You can also get the distribution of agent, on which one were built by your organization or on other platforms, and on what platform they were built, Copilot Studio, Microsoft Foundry, or other. It also provides you with the top actions you need to take in order to stay on top of your security posture and your health, agent's health. If you go into the agent inventory, you can see exactly the total number of agents you have in your organization. nice number, or more than 100,000 agents. And for each agent, you can see what platform it was built on, what's its availability, what its security risk, and its adoption. All of this is powered by Microsoft Entra Registry. And Microsoft Entra Agent ID now enables you to register and manage agent, to govern agent identities and lifecycle, and to protect agent access to resources. So in the Microsoft Entra Admin Center, you can see also all your total agents, what is their activity, what policies do they have. And in the agent registry, you can see again all your agents, where they were built on, which ones have Entra Agent ID and which doesn't. So Agent 365 and Entra are for all your agents, regardless where they were built on. Looking at another top concern, the supply chain compromise. How do we do that? So here, you want to protect AI from build to runtime. You want to get visibility across all your AI asset. Again, what we can't see, we can't secure. You want to see the agents. You want to see the models. You want to see the data, the tools they connect to. You want to manage your posture and reduce the risk. You want to identify vulnerabilities and misconfiguration. And you want to defend against specific threats and continuously monitor that. So Defender can now has posture management for agent and threat protection for agent. You can identify vulnerabilities and misconfiguration. You get the full posture and the attack path, and you get threat protection for agents. And we'll start quickly with the managed posture for agents. So you get the visibility across all your agent from Foundry and Copilot Studio. You see the vulnerabilities and misconfiguration, and you can see attack paths. So in Defender now, under the asset, you have a new category, AI agents, where you can see all your agent across Foundry and Copilot Studio. You can drill down into an agent. For example, here is Java Assist. You can see what model was built on. You can see recommendations. You can see, for example, that this agent has two recommendations. And if you recall the system prompt, it tells you that this agent was not built correctly, that the operational instruction, the system prompt, is not correct. This means that this agent is can be attacked easier. It also gives you the remediation. What do you need to do in order to prevent that? And it shows you the attack path. So for example, this agent is open to the internet, so it's weaker. It shows you where you need to solve the problems, to get recommendation. It shows you exactly what remediation you have in order to start secure. And this, what you saw here in Defender, is available for security team. But we said security is a team sport. We want the developer to also see this. So in Foundry control plane, everything is now available also to the developer. Developer also can observe, secure the agent, gets the recommendation, and manage the agent across all their agents. With built-in security, same thing. Entra, Purview, Defender, all built in. So for example, in Foundry control plane, these recommendations are now available also for the developer, so he can take action and fix these. One more thing that we have is we talked about XPIA and prompt injection. So in Defender, you now also have threat protection. You can protect against and respond to threats in real time. You can get agent security alerts and incidents, and you can get remediation and guidance on what to do. And as you saw, in Foundry, you have all these controls. So the first thing for threat protection, you want to put the controls in place. You want to have prevent for sensitive data leakage. You want to make sure that your agents are task adherent. So a new control that was released in Foundry is the task adherence. Ensure that agent does not drift from the task. So ensure that it does what the user asks, but also adheres to the task, the developer system prompt, and adheres to the task. Agent hijacking, prompt injection, all of that, and of course, content and harm. So what happens is when you have the guardrail, when somebody does prompt inject into the agent, Foundry will automatically block this. But at the same time, the security team will get an alert, an incident. For example, here, there is an attack on the procurement agent. If they drill down, they can see that this procurement agent, there was a phishing alert, there was a jailbreak alert. They can drill down into the jailbreak alert and see exactly what happened. And they can also see the suspicious prompt and what the attacker was trying to do. And this is very powerful because this gives the security team the visibility to see the intent of the attacker, to know what he's trying to do. And we all know he's probably not attacking only through one place, so they can investigate and hunt. We're going to skip the next example due to time. You know, we do quickly. We're just going to say, Purview for data security enables you to have data security and compliance across your organization. And you can see in Purview now again, give visibility of all your agent, and what are the risky agent, what data they're accessing, what are they doing with the agent. You have a full list of all the agents, which agents are high risk, what is happening, which agents, what are the data they're accessing, what are they doing. And if we look at the Java procurement agent again, for example, we see that Purview detected that this agent is high risk and has different risk here and quarantined this agent. And you can drill down and see exactly that this agent communicate what is doing, what sensitive data it's accessing, and get all the details. So you can see that we can tackle the biggest challenges, agent sprawl, data oversharing, shadow AI, and vulnerabilities, and of course, regularity and compliance. And Microsoft Security provides you together the data security, the threat protection, the identity access, and the AI governance across all your agents, Copilot, Copilot Studio, Foundry, and other AI apps and models, and of course, other platforms. So overall, you have full security for your AI agents, and AI, of course. And we have been continuously innovating, so just as a glimpse, I'll close it with all the new capabilities for the managed agent sprawl, the preventing data leakage and oversharing, the access and vulnerabilities, and of course, the compliance. And with that, I'll open it to questions.
We have a mic there if people have questions.
Okay.
All right.
Thank you so much.
Yeah, thank you all. Appreciate it.